For nearly a century, one story has dominated our understanding of everything. It's the story of a universe born from a single point, expanding for 13.8 billion years. The Big Bang. It's the foundation of modern cosmology, held up by pillars of evidence like the expansion of space and the faint leftover heat of creation, the cosmic microwave background. But what if the story isn't so simple? What if our newest, most powerful eye in the sky, the James Webb Space Telescope, is showing us things that just don't fit? It's sending back data so unexpected, so puzzling, that it's forcing scientists to rethink cosmic history. While the Big Bang is far from being overthrown, the discoveries are so significant that some are asking questions that were once unthinkable, challenging the very core of our cosmic creation story. The James Webb Telescope was supposed to confirm our theories about the early universe. Instead, it's thrown cosmology into a state of thrilling chaos. It has found galaxies that shouldn't exist. It has measured cosmic expansion in a way that creates a crisis for our models. It's even led some researchers to whisper about radical alternatives, ideas once considered scientific heresy. This isn't just about tweaking the details, this is about facing the possibility that our grand story of the universe might be missing a key chapter. Or maybe it's a different story altogether. According to the standard Big Bang model, the first few 100 million years of the universe should have been a quiet time. Galaxies were supposed to build up gradually, growing from smaller pieces over billions of years. So, astronomers expected JWST to spot tiny baby galaxies in the cosmic dawn. What it found instead were monsters. JWST has detected galaxies that are shockingly massive and mature, popping up just 300 to 400 million years after the Big Bang. Take JADE's GSZ 14-0, one of the most distant galaxies ever confirmed. It was already there when the universe was only 2% of its current age. And these aren't just little clumps of stars. Some of these ancient galaxies are nearly as big as our own Milky Way. Based on our models, there just shouldn't have been enough time for them to get so huge so fast. This discovery was a genuine shock. It's like finding a fully grown redwood tree in a greenhouse where you only expected to see seedlings. It suggests that star formation in the early universe was way more efficient than we ever predicted. This doesn't mean the Big Bang didn't happen, but it does mean our understanding of what happened after, the part of the story that explains how galaxies actually formed, is seriously incomplete or maybe even wrong. These impossible galaxies are the first major crack in the standard narrative that JWST has blasted open. Another pillar of cosmology is the Hubble constant, the speed limit of our expanding universe. And for years there's been a nagging disagreement in how we measure this number, a problem that's earned the dramatic name, the Hubble tension. There are two main ways to measure it. The first looks at the early universe by studying the cosmic microwave background, the afterglow of the Big Bang. This gives us a prediction for how fast the universe should be expanding today. The other method measures the expansion rate locally by looking at stars and exploding supernovae in galaxies closer to us. The problem? The numbers don't match. Local measurements consistently show the universe expanding faster than the predictions from the early universe suggest. Scientists hoped it was just a measurement error, but then JWST, with its incredible precision, weighed in. Its observations have largely confirmed the local measurements, making the tension much harder to ignore. But it's a complicated picture. Some recent analyses using JWST data have hinted the tension might be easing. One study, led by University of Chicago professor Wendy Friedman, suggested that with more precise data, the numbers might actually line up after all. Yet other studies have doubled down, reinforcing the discrepancy and calling it a full-blown crisis for cosmology. This back-and-forth debate points to the idea that our standard model of the cosmos, called lambda CDM, might be missing a key ingredient. Maybe there's a new particle we don't know about. Or perhaps our understanding of gravity or dark energy needs a major update. The cosmic microwave background has always been seen as the ultimate proof of the Big Bang, a perfect baby picture of the universe. But what if that picture isn't as pure as we thought? New and very speculative research sparked by JWST's findings is proposing a wild idea. It starts with those impossible early galaxies. If the early universe was packed with way more massive bright galaxies than we thought, they would have produced a ton of radiation. A recent study proposes that the combined glow from all these ancient galaxies, stretched out over 13 billion years by cosmic expansion, could create a background signal that looks almost exactly like the CMB. This theory suggests that what we call the CMB might not just be the echo of the Big Bang, it could be partially or maybe even entirely contaminated by the light from the very first monster galaxies. If this idea holds any water, the implications are huge. Many of our core calculations, like the precise age of the universe and its expansion rate, are based on the CMB being a pure primordial signal. If it's not, those numbers could be way off. Now, this is still a fringe idea, and most cosmologists are sticking with the CMB as the Big Bang's echo. But the fact that a challenge this fundamental is even being discussed shows just how much JWST is shaking things up. Maybe the weirdest puzzle to come from JWST data is a hint that the universe isn't quite as random as we assumed. A core principle in cosmology is that on the biggest scales, the universe is isotropic. It looks the same in all directions. That means galaxies should spin randomly with about a 50-50 split between clockwise and counterclockwise. But that's not what some studies are finding. An analysis of hundreds of distant galaxies in JWST's deep field images found a weird imbalance. About 2/3 of the spiral galaxies they could see appeared to be spinning the same way, clockwise. In a random universe, that's incredibly unlikely. It hints at a hidden, large-scale order, a kind of cosmic scale axis. Scientists are being extremely cautious about this. The finding is new and needs way more data to be confirmed. It might just be an observational bias. Maybe the way our own galaxy is spinning is messing with how we see the others. But if this cosmic spin is real, it completely challenges our understanding of how the universe began. It would mean the universe was born with some kind of rotation. This is what science looks like in real time. It's messy, it's confusing, and it's unbelievably exciting. If you find these cosmic mysteries as fascinating as we do, make sure to subscribe and hit that notification bell. We're just beginning to understand what JWST is telling us, and you won't want to miss what happens next. That puzzle of a spinning universe has breathed new life into one of the most mind-bending ideas out there: black hole cosmology. This theory suggests that our entire observable universe exists inside the event horizon of a black hole, which itself is in a much larger parent universe. Championed by physicists like Nikodem Podlarsky, the theory proposes that when matter collapses into a black hole, it doesn't get crushed into an infinitely dense point. Instead, quantum effects make it bounce and start expanding again, forming a new baby universe inside. This could mean that every black hole in our own cosmos is a potential doorway to another universe forever hidden from our sight. For decades, this was just a cool, untestable idea, but the JWST finding of a potential cosmic spin could, in theory, be evidence for it. If our universe was born from a spinning black hole in a parent universe, it might have inherited that spin, creating the lopsided galaxy rotation. To be clear, this is absolutely a fringe theory and not widely accepted, but the fact that JWST is raising puzzles that an idea this wild could potentially solve shows just how big the challenge is. This telescope is forcing scientists to consider every possibility, no matter how strange. So, is the Big Bang actually dead? The overwhelming answer from cosmologists is no. The title of this video reflects the fierce debate and a handful of scientists exploring alternatives. The core evidence for the Big Bang, the expansion of the universe, the existence of the CMB, the amount of light elements, is still solid. What JWST has killed is not the Big Bang itself, but our certainty about the details. It has shown us that the universe's evolution was far more complex and surprising than our models ever allowed. The standard lambda CDM model is being stretched, not because it's wrong, but because it's obviously incomplete. The impossible galaxies, the Hubble crisis, the questions about the CMB, and the mystery of a cosmic spin aren't failures of science. They're its greatest triumphs. These are the moments when new data forces us to look past our assumptions and toward a deeper, truer understanding of the cosmos. The Big Bang theory is being pressure tested and upgraded, not thrown out. The story of our universe didn't end with the Big Bang's discovery. Thanks to the James Webb Space Telescope, we're realizing a thrilling new chapter is just beginning.